So starting off with the first chapter in the Pure 1 textbook, we'll be looking at algebraic expressions. In this video, we're going to be looking at index notations. So an index notation is when we have a form a to the power of n. This a is known as the base, and this n is known as the index. Sometimes it's also known as the power or the exponent. So if we have, for example, 2 squared, it just means 2 times 2. 4 to the power of 4 means 4 times 4 times 4 times 4. So now we can apply some indices rules. So if we have the same base, and we are multiplying them together, for example, 4 squared times 4 cubed, then all we have to do is sum up the two powers. So 4 squared times 4 cubed will be 4 to the power of 2 plus 3, 4 to the power of 5. This also works when we're dividing. So if you have the same base again, and we're dividing two terms, then all we have to do is subtract the powers. So for example, 4 to the power of 5 over 4 squared will be 4 to the power of 5 minus 2, 4 cubed. Now if you have an expression which has been raised to a power, and then we raise that to another power, then all we have to do is multiply the two powers together. So for example, a to the power of m, which has been raised to the power of p, will be a to the power of mp. So let's say 2 squared to the power of 4 will be the same thing as 2 to the power of 2 times 4, 2 to the power of 8. And finally, if we multiply two numbers together and raise that to the power, that's the same thing as saying we raise each individual number to the power and then multiply them together. So a times b to the power of n will be the same thing as a to the power of n times b to the power of n. And using these rules, we can go ahead and simplify certain expressions. If the base is not the same, then we can't use the first two rules. So we have to actually make the bases the same, and we'll go through some examples later on looking at these cases. So let's look at this example here. So we have 2 squared times 2 to the power of 3. That's the same thing as 2 to the power of 2 plus 3, 2 to the power of 5, that's 32. Let's try this one here. So 3 to the power of 4 over 3 squared, that's the same thing as 3 to the power of 4 minus 2, 3 squared, which is 9. This one here, so 2 squared to the power of 3, that's the same thing as 2 to the power of 2 times 3, 2 to the power of 6, that's going to give us 64. And finally, 2x all raised to the power of 5. This can be rewritten as 2 to the power of 5 times x to the power of 5, so 32 times x to the power of 5. Right, let's look at this example here. You notice that the bases are no longer the same. So in this case, the base is 8, and this one, the base is 32. So to make sure that bases are the same, the way we do that is we look at each base individually and try and find the common factor. So 8 I can say is the same thing as 2 cubed, and 32 I can say is the same thing as 2 to the power of 5. If we go ahead and replace that, it's going to be 2 cubed to the power of 3 times 2 to the power of 5 to the power of 2. This is going to simplify to 2 to the power of 9 times 2 to the power of 10, which is the same thing as 2 to the power of 19. So this is an example of us changing the base in order to use some of the rules. If we look at this example here, we have certain different terms. We have to make sure that we only apply the laws to each base which are the same. So if we have 4x squared to the power of 2 divided by 2x cubed to the power of 3, then let's go ahead and simplify each term separately. So 4x squared to the power of 2 will be the same thing as 16x to the power of 4, divided by the second term, we can say is 8x to the power of 9. Now we can go ahead and divide. So 16 over 8 will be 2, and the x is x to the power of 4 divided by x to the power of 9 will be x to the power of minus 5. So it'll be 2x to the power of minus 5. And the final one is this kind of example here. So we have 3 to the power of 2n plus 1 is equal to 27 to the power of n minus 1. Once again, we have to make sure the bases are the same. So 27 I can rewrite as 3 cubed, and therefore I can say it's going to be 3 cubed and then to the power of n minus 1, which will simplify to 3 to the power of 3n minus 3. And that's equal to the original 3 to the power of 2n plus 1. Because now they have the same base, I can now say the powers are the same. So 2n plus 1 is equal to 3n minus 3, therefore n I get 4. So this first video you guys should have learned already, so just take some time to practice some of the questions that I have listed out after the video.